Welcome to this eLearn security video lesson on Meterpreter, SSL certificate impersonation, and detection evasion. In this video, we're going to cover the advantages of utilizing custom SSL certificates as they relate to Meterpreter sessions. As monitoring solutions and defenders up their game detecting the work of the red team, it is up to us to find ways to better obfuscate or encrypt our traffic and actions as we compromise and move throughout an infrastructure. As with most open source tools we use regularly, over time, signatures are created to detect the traffic these tools generate, and these signatures are then implemented for use with intrusion detection systems, which end up flagging a lot of our activity, particularly when using tools in their default, out-of-the-box configurations. Fortunately, in regards to Metasploit's Meterpreter handlers and payloads, we can configure our own SSL certificates for our own payloads and handler, which will encrypt our traffic to and from our target system, making it harder to detect on the wire. Before we get into the custom SSL certificate configuration though, let's have a quick look at the traffic between a reverse_HTTPS handler and payload configured with default settings. In other words, we'll generate a payload and configure a Meterpreter handler without any additional or custom SSL configuration. First, let's generate a Meterpreter reverse_HTTPS payload with MSF Venom, and we'll call it default_payload.exe. Next, we'll fire up a multi-handler and configure it with our lhost, lport, and payload options. Once we've generated our payload and started our handler, let's get the executable payload over to the target system, which is on the right-hand side of the screen. For this, we'll fire up a Python HTTP server on our attacker machine, and then use a PowerShell download cradle to download our payload to the target into the C:/program data directory. Next, we'll execute our payload on the target while also running a packet capture using Wireshark. What we're trying to identify here are indicators in the SSL traffic between our target and attacker that could be used to detect our activities. First, we'll launch Wireshark, and then we'll execute our payload. Now, if we set our filter for SSL traffic, we should end up with a stream of just the SSL data. Now that we've captured SSL packets, if we right-click on a frame that's part of this stream, select Follow and then TCP Stream. We can get a better look at this data in ASCII format. What we're seeing here is the contents of the server hello SSL packet. This packet contains SSL certificate information and is passed to the client in clear text over the wire. It's these randomly generated SSL certificate strings that will likely flag our payloads and potentially disrupt our operations. This certificate information is automatically generated by Metasploit when we use default Meterpreter options, and it's this information that will be flagged as suspicious traffic in regards to over-the-wire anomalous traffic detection mechanisms. Now that we've seen what some of the default traffic looks like between a Meterpreter HTTPS payload and handler, let's see what options we have available in order to better reduce our chances of being detected. One module we can use in Metasploit is the Impersonate_SSL module. Essentially, this module will request a copy of an SSL certificate from a site of our choosing. We'll create a self-signed version of the certificate and private key we can then use to configure our payload and handler with. This will allow us to somewhat impersonate the SSL certificate information and can certainly help in evading over-the-wire heuristics. We can view information about this module with the info command. There's only one option we need to configure with this module for our purposes, and that is the rhost option. For this demonstration, we're going to use the www.microsoft.com as the domain whose certificate we'd like to copy. We can simply set the rhost value to www.microsoft.com and then run the module. We can leave the rest at their default settings. After we run the module, we can see that Metasploit has created a CRT certificate file in addition to the private.key file, as well as a combined .pem file, which is the one we'll use for configuring our payload and handler. Let's copy the path to the PEM file to our clipboard, as we'll need that in a bit. Now that we've generated the SSL certificate we'd like to use for impersonation, let's generate a new payload executable. Rather than use MSF Venom this time, we'll generate our payload directly from within Metasploit. Next, once we configure our lhost and lport options, we're going to set the handler SSL cert option and set that to the path of the SSL.pem file we generated earlier. Another option we're going to use for our payload is the Stager Verify SSL cert option. We'll set that to true. This option will make it more difficult for defenders to intercept our SSL traffic by enabling TLS pinning. And finally, we can generate our payload with the generate-txe command and also specify the directory we'd like to save it into. We'll call our new payload ssl_payload.exe. So far, we've copied SSL certificate information from the www.microsoft.com website and generated a payload executable using the handler SSL cert and Stager Verify SSL cert options to use our Microsoft.com SSL certificate. Next, we need to configure a handler with the same information. We'll use a multi-handler and set it with the same SSL options as we did for our payload executable. Lastly, let's get our new payload executable over to the target and ready for execution. Again, we'll use the Python HTTP server and a PowerShell download cradle from the target to download our payload executable into the C:/program data directory. But first, let's modify our download cradle to download the new payload. Now that our executable payload has been downloaded to the target, let's once again run Wireshark and then execute the payload, and then we'll take a look at the SSL traffic and confirm that we're now seeing our Microsoft SSL information passing over the wire. As we did before, we set our filter for just SSL packets. We can right-click on the first packet, select Follow, and then TCP Stream like we did earlier. As we can see, in the packet capture, we're no longer seeing default Meterpreter SSL traffic, but rather, our traffic is impersonating an SSL connection to our attacker system using Microsoft's SSL certificate information. These small changes to the way we build our payloads and handlers will certainly go a long way in regards to evading defenses that may be in place during an engagement. And this concludes our video lesson on Meterpreter SSL certificate impersonation and detection evasion. Thank you for joining us.